Okay, so before we move on, I'm going to talk about a bit about analytic thinking and making data-driven decisions and how we define business problems. So what exactly is analytical thinking? Analytical thinking is the ability to identify and define problems, extract key information from the data, and develop a workable solution for the problems identified in order to test and verify the cause of the problem and develop solutions to resolve the problems identified. Now, this seems like a bit of a mouthful, and I admit it is, but look at the keywords here. To be analytical thinking, to adopt that mindset, basically we have to look at a problem. Just think of any business problem you can find of, like maybe sales are dropping in a particular store in a certain region. So that's the problem. We identify the problem and we extract key information from the data just to basically identify and be more granular to figure out what is happening in that area. And now we take that data, the analysis of it, develop a solution for the problem identified, and then we have to test and verify that this is the cause of the problem. And maybe we have to try this a couple times to see what actually works in the end, because this means we're going to develop a solution to resolve the problem here. So that's basically what it is. And let's look at data analytical thinking. So for businesses who utilize data analysis and data-driven decision-making is critical. It's so critical that it can almost blind them sometimes, but just remember it is critical. So before we go ahead, before you go ahead solving and attempting to look at data, you basically have to have a deep understanding of the business problem. And that is the domain, basically like suppose you're trying to solve a problem in the insurance domain, and you basically don't understand like why people buy insurances or what this type of insurance is for. So you're going to be making wrong assumptions maybe right from the get-go, and that's not good. And also you need to know how this data is generated. Like, for example, imagine you built a model, all right, that was 97% accurate in this disease detection. It's pretty good, right? Perhaps, but suppose it missed 3% of the patients who actually had it. So now you're testing, let's say you're testing for Ebola, and 3% of the patients who had Ebola, our test didn't pick it up. Think about it. People who have Ebola are not being detected, even though our 3% of those people, even though our test is 97% accurate. That is not good at all. Okay? So it's quite preferable to have a model that is less accurate, 90% accurate, but it never failed to detect the disease. So basically it means the test was super sensitive, which means that it's probably going to, like people who don't have Ebola, it's probably going to identify some of them having Ebola, which it may scare them, to be honest, and may get put on the quarantine, blah, blah, blah. But you know what? It's better we actually quarantine those people rather than have 3% of people who had Ebola go back into the general population and spread that disease. So while I admit, by the way, this doesn't relate to where I was going with this, how the data is generated, it is an example of basically how you think about business problems, like the solution to it. Like, is this what we want, or is this what we want, or is this what we want? Or how do we find a balance that satisfies all parties? So it's important to know when you're thinking with data that you tend to have to actually use the data wisely in a way that you actually solve the problem at hand. So exactly, many times companies can hire the best data scientists who are technical geniuses. They can create elaborate models, super accurate, all those things. However, they can miss the big picture and probably lead to some... It happened to me a couple times where I spent like days doing analysis only to come up with something that was quite obvious to everyone else. But at least I had data to prove it. So some key points here. Data should be improving the decision making, not misleading or adding to the confusion. A great data scientist needs to understand the business domain you're working in, the goal of the model, that is, what is a problem they're solving, the statistical weaknesses of their model, like we go back to that Ebola detector, where we can actually tell someone you're going to learn all this in the course, by the way, how to assess your models, but we need to know what is the weaknesses of their work and how it can be improved, or if it can be improved. And this one is of utmost importance, how to communicate your findings effectively. Like, I've had trouble with this, to be fair. I think everyone has at some point, where you come up with this fancy presentation, all these graphs and stuff, and you present it, and everyone's confused. And you end up spending like a half hour, or maybe longer, just trying to explain your results to people who are becoming increasingly skeptical because you're there bumbling around trying to explain stuff and no one is listening. So if you have something key to show, bring it up first. Show the key findings first. Then you drill down deeper and deeper in how you got this. So allow them to ask questions, allow them to understand, ask questions, and then you verify and back up your stuff.